Hello and welcome to today's CAMWorks webinar. My name is Tyler Reid and I am the manufacturing specialist here at GoEngineer. Today's webinar is intended to be sort of a tips and tricks presentation. It's going to last about 30 minutes. I had some questions, some good questions this week about machining in assembly mode, and so I decided to do the webinar on that subject today. So we're going to spend about a half an hour going over some tips and tricks that I think are useful, machining in assembly mode within CAMWorks. There's going to be some steps here at the beginning that are very important. I'll spell those out. And there's also going to be one big thing to remember at the beginning here is that assembly mode is only accessible in milling mode. So if you are doing turning or if you're doing mill turn and you try to create an assembly, you're going to be wasting a few minutes of your day when you try to program it inside CAMWorks. So we're going to be doing some just 2.5 axis milling here. You can go up to 3, 4, 5 axis milling inside assembly, and I've done that in other videos. So I think I'm going to stick with the 2.5 axis today and show more of the ins and outs relating to choosing the stock and work offsets and sorting machine operations and stuff like that. So here I've got an assembly, a SolidWorks assembly. If you're new to SolidWorks, it may be worth checking out one of GoEngineer's YouTube videos on creating assemblies, because that's going to be a basic step here, and I'm not going to go over it. So we've got an assembly here. It's set up the same way we were planning on intending machining our parts. So we've got the same part here, except I've got some instances that are facing upwards, and I've got some instances that are facing downwards. We're going to program all of these in the context of one program, and we're going to do it a couple different ways using a couple different types of stock. Before I go on here, I should mention that this is a webinar. This is live. Everybody is free to ask questions here, but please do so in the questions box in your GoToMeeting because everybody's muted, and we'll take questions at the end. All right, so let's continue. I've got my assembly, I've got some parts here. I do have what we call a SolidWorks coordinate system in my feature tree. It's listed over here as SolidWorks coordinate system 1. The inclusion of a coordinate system for the CAMWorks purposes is very important. And so I'm going to go over how to create that. It's a SolidWorks function. In the SolidWorks assembly tab, it's going to be listed under if you can't remember where it's listed, it's going to be listed under reference geometry. But if you can't remember where it's listed, there's always the nice the search box up top. You can start to type coordinate system and it brings it up for you. And then if you want a nice reminder of where that is, you can hit the little eyeglass icon and it'll point it out for you. All right, so it's going to be listed under coordinate system. It's going to bring a box up asking for some inputs. The first input is going to be the origin point. This is going to be a vertex of sorts. Where you place this coordinate system can have a big effect. It's not going to be critical, the placement here in the 2.5 axis mode, because we're going to set our coordinate systems and our part setups independently. But if we were programming in like a 4-axis mode where we have, say, a tombstone or a rotary axis, it's very important that this coordinate system that we're creating now is placed at the center of rotation on your machine, all right? Because the CAMWorks axes are going to be defined by those. In 2.5 axis, it's kind of arbitrary. Really what we're after here is a Z direction, because in CAMWorks assembly mode, it only machines from one direction. It's always going to be the Z direction. So I could pick a spot here on my fixture plate, and if the coordinate system pops in a good direction, you can just keep it that way. If it doesn't pop in a good direction, then we're going to set the X, Y, Z axes just by clicking on edges or sketch lines. All right, so now I've got a coordinate system in here. That's key. You're going to have to do that every time in assembly mode. Now we can hop over to the CAMWorks feature tree. You double click on the machine entry, choose a machine if you need to. Obviously choose a tool crib and choose a post processor if you need to. Most of what we do here is going to be very similar to how we program in part mode. One difference within the machine definition here is we're going to go to the setup tab. And this is where we read in that coordinate system. And this is how it picks up the Z direction. So this is all very important. If we were in a 4-axis mode or a 5-axis mode, then we would have to select 4 or 5-axis indexing in this indexing dropdown, and then we would set a rotary and a tilt axis around an XYZ axis up from that coordinate system. All right, but we're setting it to none here. So that's step one that's different in assembly mode, is the creation of that coordinate system and reading it in. The second difference here is going to be the part manager. So this is going to be a new entry if you've only programmed in the part mode, this part manager entry. We'll double click in here. This is where we're going to tell CAMWorks what parts we're going to machine, because there's obviously parts in this assembly that we are not going to machine. Things like the table and the fixture plate and these bolts. Those are there for good reason. We're going to tell CAMWorks to avoid those, and also help us set up our assembly, align our parts, but we don't want to machine them. So we have to tell CAMWorks, machine this part. We can click on a part. If there's multiples of these parts, we can simply highlight it and say add all instances, and it's going to add all of these. A couple other buttons here. One's a checkbox, this subprogram. It's either on or it's off. This has to do with the G code. When we post out our code, is it going to be long form or is it going to be in subprograms or subroutines? This subprogramming will give you shorter code to read, and it also helps if there's going to be any sort of changes done on the fly at the machine. But make sure your post processor supports that. So if you want to program in subroutines, mark that box, post it out, and if it looks good, good. And if it doesn't, get in contact with us and we can enable that in your post processor. There's a couple of other buttons in here that we're going to come back to. And these are going to help us group these together. So the way I have it set up right now is CAMWorks is going to try to machine each of these parts individually. Okay, but there might be instances where we want to keep parts set up as a group. A good example of that would be if I had, say, several stages of a part that are going to be cut in succession. I might group them up. But I'll give an example of that in a bit here. So go ahead and we're going to hit OK. Now it knows what parts we need to cut. It's going to list that part under the part manager. One entry here because all of these parts are the same part. If we had multiple parts here, then each part would be listed under the part manager. We have a feature manager and we have instances. So the feature manager is going to be the same as what we deal with inside part mode. And then the instances is going to show us, the number of instances that are related to this listing of the part. That's difference number 2, the part manager. And we will come back to that in a bit. Difference number 3, the stock manager. So when I highlight the stock manager here, notice that each part has its own stock. This may or may not be how you plan on programming the part. Double clicking into the stock manager is going to bring up a window that's going to be mostly familiar, again from the part mode. We can set our material. We can choose our stock type, our bounding box, our extruded sketch, our STL file, and one extra option now is we can read in a part file. So this is a very common way to program in assembly mode, is you have 2 different part files that are kind of mated so that they're right over top of each other. And one is, say, a raw casting, for example, and one is the part after the casting's been machined. And then you would set one part as your stock and one part you would read in as the part manager to be cut. So part as stock is new. Other boxes that are new here, the number of stocks area, and then our stock. So we have several different stocks listed here. Each listing, as I scroll down through this, is an instance of the stock. In the next area, create stock, we have 3 buttons: separate, common, and apply the current one to the rest. So we're going to be using this one, these first 2. So in many cases, we want parts to share stock. And we can do that by highlighting multiple parts and setting the stock all as, say, a shared stock. So I could highlight all parts and say common stock. And now if you notice, I have just one part, one stock listed, and in my preview, one giant stock. And then from there, I can add offsets just like in part mode. XYZ offsets that read from the XYZ coordinate system inside SolidWorks. I could have chose groups of parts to share a stock as well. I obviously didn't have to do every part. But for this first example, we're just going to do that. So that's difference number 3. We've got some differences in the stock manager. At this point, it would be time to start programming. So in part mode, we usually start our programming by running the feature recognition and checking to see what features it gives us. And in a lot of cases, it will create multiple setups because it will create setups in every direction that it finds features. It works the same way in assembly mode, but it actually will end up giving us 2 feature trees. So I'm going to go ahead and run the feature recognition here. And the first thing you're going to notice is on the left side, we basically have 2 feature trees. We have all of our features listed in the top area and in the bottom area. So there's some differences between these two, and this to me is one of the most confusing aspects of machining in assembly mode at first. Is what are the differences between these 2 feature trees, and how do they interact with each other? So the first feature tree, we really will call it the feature manager. And it's tied to our part. It's got 2 setups here because it found features coming from 2 directions, the top and the bottom. All right, and then on feature 2. Notice if I right click under this part setup, I can add features and I can add milling operations. In this setup, notice when I highlight or hover over a feature, it highlights the features for every instance. All right, so this top feature tree is where you would add features. It's where you can specifically add operations. And it's really tied to just this first part, but then it's propagated to the rest of the instances that are listed here. So note, in this bottom setup, all of the instances are labeled. I can expand this out, and I see my instances here. In some cases, I may need to suppress these instances, and we can do that. A good example of that would be a face feature. I don't have a face feature in this part, though. But just to give you an idea of what that would look like, say this open pocket here, which we're going to end up deleting anyway, it looks like. But if I only wanted the open pocket for this first part to be cut, I could simply shift-click all of these instances, suppress them, and now it's just the one part. So again, I think that's most commonly used with a face feature, so that you're facing off all of the parts together instead of, in this case, it looks like I've got 18 parts, 18 separate face features that are all going to be cut separately. Notice if I right-click down in this setup, I can't add a feature down here. So features are always added manually up in the top area. Let's talk about this open pocket. So note this open pocket, it's extending out through the entire stock, but it's only picking up this one island. And this is one of the problems I've run into with the open pocket feature specifically in assembly mode, is that you can't pick up islands from other parts. If we were to keep this as an open pocket with the stock extents option, we'd actually have to define avoid areas for each one of these spots here. I could edit this open pocket feature, uncheck the use stock extents, and that would rein it in to just cover the one part. That might be a better idea. And then unsuppress all of these instances. This might be one way to do it. A second option might be to use a sketch and define a pocket from a sketch, but we'd also have to create some avoid features there. So the open pocket one is a tough one in assembly mode. All right, so at this point now, I'm going to generate my operation plan. And that runs all of those features through the database, kicks us over to the operation tree, and we have our features listed here. One thing to note here as I hover over this, CAMWorks does a good job of only attacking features that it can cut from the Z direction. So for example, this pocket, it does exist on this part over here. It's on the underside. You see, it's right here. But CAMWorks doesn't try to cut it because it can't reach it from the Z direction. So I have a lot of toolpath on this already. Some of these tool choices though in this default database, I'm sure people have noticed here, is that in this default inch database, we've got some funky tool choices. And one of those is this 6-inch end mill. Let's choose a new tool here. Maybe a 3/4 inch end mill. Much better. The manipulation of the toolpaths and the manipulation of the operation parameters is all the same as in part mode. We'll go ahead and choose a new tool here as well. I've covered this in several videos, but I think it's always worth mentioning. If you do have a bad value in your database, like that 6-inch tool, change it and then make that change, save it back to your database. You can do that by finding the feature that it's tied to, Open Pocket 1. And then in the bottom setup, you're going to say Save Operation Plan and just overwrite the existing feature condition. So I'm updating what's in the database for that feature condition. So I'll never get that 6-inch tool out of there again in either the rough mill or the contour mill because I save both of them at the same time because they're both tied to the same feature. All right, so I've got a lot of toolpath here, but this isn't a very efficient way to cut these parts. In a lot of cases, we want to optimize this. So under each operation, under the Optimize tab, we can optimize these by going grid, shortest path, outside to in, inside to out, on an operation basis. We can also control the order that it's cut in using the part manager. The way it found the parts, the order that it found the parts is the order it's going to want to cut in general. So we can drag and drop these in different orders as well. But the way that I have it now, with just a single setup for both these parts and these parts, there's not much sorting beyond that I might do that I wouldn't have already done in the 2.5 axis mode. Really just right clicking on the setup itself, sort operations, and then sort by operation type and by tool. You know, we do that all the time in part mode. All right, so if we want to see what this code would look like if I have subprograms selected, we can post-process this. And we can see it groups it up by operation type. We've got our center drill. We've got the coordinates for all of the center drills. And then at the bottom, the long code is just posted a single time. So the subprograms can help a lot. All right, so let's talk about some of the other intricacies that can come up with assembly mode. I'm going to readjust my stock, and actually let's do this. Let's just create a second configuration here. And by starting a new configuration, I can basically start over while still retaining my old info. So I can always access it back. Configurations are used quite a bit in assembly mode, not for the reason I just used it, but for the simple fact that we can only machine in one direction. So if you imagine if I had an assembly that didn't have both sides of these parts, I just had one side and then I was going to cut that and then flip every part over and then cut that again. I'd have two programs and I'd actually have to program that in one configuration with the top side up and one configuration with the bottom side up. And I get away with doing that in one assembly file by coming over to my assembly tree and my mates and suppressing and configuring my mates, which again is kind of a SolidWorks issue. So if that kind of interests you, definitely shoot me an email at the end of this or call into our tech support. We can help you with that. Okay, so we're going to step through this again. We come into the part manager. I'm going to add all instances of this part. Actually, I'm going to click through them fairly quickly so that I can control the order. Because what I'm going to end up doing here is grouping these, and if they're in order, it's going to make my life easier. Okay, is that the best way to do it? I'm not sure, but that's the way I'm doing it. So notice how these are grouped in this window. We have one grouping of the part and then all of the instances. By doing it this way, we have to have the same features across all parts. And we're also going to have some issues if we wanted to have separate work offsets for two groups of parts. I skipped over the work offsets in the last example, so we'll jump back to that in a second here. But anyway, ideally what we want here is I want to create a program for this group, and I want to create a program for this group. The way I'm going to do that is I'm going to sort the instances in here. So I'm going to find the first instance here, and I'm going to say split instance. And now I have two headings. See this? I got a heading here and a heading here. I'm going to drag and drop the rest of these over to the second instance. So just shift select. Ooh, I'm going to have to do each one individually here. All right. And then as soon as I've finished with this, we'll go ahead and say OK. And now I'm going to have two instances listed in the part manager with two feature managers up here. So now I can have separate features for each part. In this case, I have a whole group that's facing up and a whole group that's facing down, but that might not always be the case. Imagine, again, a scenario where we're stepping through stages of a part, where we say we have a fixture, and on the left-hand side of the fixture, we're going to have a fresh part. In the middle of the fixture, we're going to have a part that has gone through the first step, and then in the right-hand side of the fixture, we have a part that's gone through the first two steps already. And each program, we're going to be, after it runs, we're just going to move the part down the line, kind of like an assembly line. That's a very common way of machining. This would be a perfect example on how to do that. So at this point, I need features again. Last time I ran extract machinable features, I extracted all of the recognizable features. In some cases, you might have already programmed this part in the part mode itself. You open up the part, you program it in here, or you did it beforehand. If that's the case, you can import that data into an assembly by right-clicking on the instance and saying import part data, and then either deleting or merging with the existing data already in the assembly. I haven't programmed this part, so, but what that would do is it would bring in all of the features, and then it would only cut, again, the ones that are in the Z level. So that's a great way to go about this. I haven't done that. I am going to control the stock here, though. So let's come into the stock. And the reason why I group these into two is because I'm planning on having two pieces of stock. And if I have two pieces of stock, imagine the issues that I might have when I go to actually machine this on the machine. I have two pieces of stock. I need to locate both pieces of stock. So the best way to do that is to have each piece of stock have its own work offset. Okay? Because if we're working off two pieces of stock but one work offset, it would be extremely difficult to replicate the assembly that as we have it in SolidWorks on the machine. We have to be able to locate those stocks precisely. So that's not going to happen. So I'm going to set two work offsets here. First, I'm going to combine all of these stocks, highlighting these and saying share a stock. And now I will do the same with the rest of these. So now I have two pieces of stock. And each of those pieces of stock corresponds to an instance here. So we're going to extract machinable features at this point. I'm going to go ahead and suppress these open pockets because I don't like these open pockets here. All right, so notice now in the feature manager setup, I double click on this. This is a window that we see in part mode, but we usually see it in a different spot. We see it in the operation parameters. But now it's here in the feature manager. So I can set a stock for this setup. Right now it's set to absolute. I can do a couple different things. I can do a stock vertex, which would put it up in the top left corner of that stock. That'd make it very simple to select that. I can, click on an arc or click on a point. I could actually select an entity and select this coordinate system as well from the feature tree in SolidWorks. So I can do all of that. I'm going to go with the stock vertex. All right, the rest of this is the same until we get up to the next spot here. So let's generate an operation plan. Generate our toolpaths. So now we're going to have to do something slightly different here, right? Because we have one setup. If we double click into this setup, we have to set the origin. The origin right now, it's tough to see. It's down here in the bottom. It's down right here. We have two options here. We have setup origin or part setup origin. Part setup origin would be if we wanted a different origin for every part. Okay, so that's actually what we would have done in the first example, is we would have where if we had used individual stock, I guess we combined that stock. So in both examples that we've done so far, we actually want the setup origin, and the setup origin is going to tie an origin to each instance that we have listed in the feature manager. So I'm going to go ahead and I'm going to say, if I use the setup origin, it's going to pull in the stock vertex. We're going to go work coordinate here. I'm skipping ahead of myself. So before I do this, I'm actually going to have to split the setups. So this is actually what I wanted to talk about. Is I only have one setup, but I actually have two stocks that need two different origins. So in order to get two different origins out of this, I need two different setups. We can right-click on a setup and say split setup. All right, and now it creates a second instance of setup one, so it's in the same direction. Then it's my job to move the features that are cut on the second stock, starting there. Highlight these and drag them down to the next setup. All right, and it's probably good practice in this case to unlink these as well. All right, so now I have total control over the setup or the work offset for each piece of stock. So we say setup origin. We're going to give this a work coordinate offset. Notice now I only have the 9 parts here. I want them all to generate off the G54 work offset. So I'm going to say G54 increment 0 and assign, and it's going to assign G54 to every part. So we have one piece of stock, we have one G54 work offset. That's exactly what we want. I'm going to do the same for this setup here. Setup origin, offset, work coordinate system 55. If I set the increment to 1 and I hit assign, notice it goes 55 through 63. So it assigns a coordinate system, a new coordinate system offset to each part. And in this case, they're all the same. So we don't want that. We're going to go 55 and 0. They're all 55. Good to go. So we've got two setups. When this posts out, it's going to post in this order. And that's going to cause us, we might be sharing some tools between the two setups, between the parts. It's usually not going to be the most efficient way to do this in assembly mode. So we're going to sort these. I should address the fixtures here before I sort them. Obviously, we have some bolts here that we're probably cutting through. Say in rough mill 1, we're cutting right through these. So we do need to address these, and that's one of the benefits of being in assembly mode, is the ability to work around your fixturing. So we do that under the Setup Fixtures tab. We can click on a part. We can say add all instances of that part, just like we did in part mode, or I can click on them. I like to click on them because in this case, for this setup, only these 9 are applicable. And then you'd say avoid all, and then when you avoid them, you have the option of avoiding a simplified shape of the fixture or the exact shape of the fixture. If you choose exact, it's going to take in any nooks and crannies that that fixture might have. It'll take in the Z level depth, but it will take a little bit longer for your toolpaths to regenerate. Simplified just takes a minimum bounding box around your part and it will generate a little bit quicker. So it's going to want to regenerate. I'm going to let that happen. When we're avoiding our fixtures, there's control in the individual operation parameters as to how you might avoid those. So in this case, for this rough mill, we would find that under the Advanced tab, Avoid Area. This clearance given is the XY clearance away from our fixture. So that changed the toolpath considerably, probably to the point where I want to choose a smaller tool. And I actually might be able to bump this down as well. Say 50 thousandths. And I'm going to do the same thing for the second setup. Come over here. Again, I'm clicking these individually because I don't want to add too many. If I add too many, it's just going to cause it to take more time to regenerate. Avoid all, simplified. Here we go. All right, so some of these toolpaths aren't generating. It's because I've got some large tools stored in that default database. All right, so now it's time to sort these. Common sorting options in the assembly mode are going to be found under the machine dropdown. Right-click on machine, sort operations here, and by right-clicking on the machine as opposed to the setup, it's going to allow us to sort by the setup, which would be the same as right-clicking on the setup, or across setups, or by and across setups, which is the most common option here. And that's going to allow us to do across the setups and also control the individual operation order or the tool order. And this is going to really minimize the amount of tool changes that we have. Otherwise, over here, as it's moving between the parts, it's going to cause it to have a lot of extra tool changes that we don't want. All right, so we apply that. And what happened now is we had a couple extra setups created. And they're linked setups. If you have a lot of different parts, or you're attacking, say you're on a tombstone and you're attacking a part from 3 different directions, when you do that sort step, it's not uncommon to have a list that jumps down to 10, 12 different setups. So you usually want to save that till the end because, at least for me personally, it makes it kind of hard to keep track of what's going on and when it's happening. All right, so that about covers what I had prepared for the assembly tips and tricks. The things to remember, just going over the list again. The creation of the SOLIDWORKS coordinate system. All right, so that's going to be done in the SOLIDWORKS tree, SOLIDWORKS toolbar, reference geometry coordinate system. Reading that coordinate system in, that's going to be done under your machine definition, setup, coordinate system here. Okay. The part manager. You enter the part manager and you control the instances of the part. Under many circumstances, they'll all be listed under the same instance because you're going to be programming them the same. They're all going to have the same features. But in some cases, you're going to want to split the instances and create separate groups if you're going to apply features to one group or the other separately. All right. And what I mean by that is it creates 2 instances here with each group, and I can control these feature managers independently of each other. I didn't do much in the way in this example, but I wanted to show how to do that. Next thing that's kind of different is the stock manager. So we control the stock of each part individually. In many cases, I'm highlighting a part and then selecting an individual stock or a common stock. I can create as many stocks as I need to. I can also create stock from a part file. All right. When I'm adding offsets, I would actually want to select the stock that I want to adjust and then add the offset. And it's only going to affect that particular stock. It won't affect the other one. So I have the first stock selected. If I move to the second one, the offsets go down to 0. So I can control them independently. The fourth difference is the control of the work offsets. And this is probably one of the most important differences here because it creates difficulty on the machining side. When you're at the machine and you can't locate your fixturing correctly, or in SolidWorks, you may have done a linear pattern. In this case, I have an 8x8 inch grid of parts, but when I go to actually set it up on the machine, my parts might not be exactly 8.000 inches away from each other. They might be 7, 9, 8. And if that's the case, and if I'm using all one work offset, I'm going to have parts that don't cut correctly. So the ability to separate and have different work offsets is extremely important. And I did that in this particular example by creating 2 stocks, splitting my setup, and then within each setup, using the setup origin option, work offset with a 0 increment. That's how I did that. Those are the main differences. One other thing that could catch some people off guard is that the machining info, the CAM info, is stored in the assembly file itself. All right, so in SolidWorks we have .sldprt files, those are part files, and we also have SLD-ASM files, those are assembly files. All of the CAM data when you're in assembly mode is stored in the assembly file. So, one kind of tip and trick here is that if you're working under an enterprise PDM system or a worker PDM system, a lot of times the machinists don't have the ability to check out parts and edit parts. So one way to get around that is to take that part file, throw it into an assembly. That assembly is outside the PDM system. Program in there, you never have to save the part file. So you're not adding any data to the part file. You're adding it to the assembly file. But the assembly file still has ties to the part file in the PDM system. So if the part file ever changes, your assembly does update and your CAM updates as well, and you can work outside the PDM system. Those are the main differences that I have. So with that, we will end the webinar here. And thank you for joining. I appreciate you guys joining my monthly webinar series. I'm open to ideas for next month's topic. So if there's something you've been dying to see, I know we've been a little short on, say, turn content and mill turn content, so we might be due for that next month. But thank you for joining. Go ahead and subscribe to our GoEngineer YouTube page. We do lots of webinars and also a lot of tips and tricks videos as well. I think I uploaded about 6 last week, so give those a watch as well. If you are interested in asking me questions offline, you can reach me at my email address. It's treid, that's TREID, at goengineer.com. Again, my name is Tyler Reid. So thank you for joining.